This is the second part of our final review for elementary algebra. Okay, we will start with the following equations. We would like to solve for x in problems 1 to 7. Solve for x. Some are equations and some are inequalities. 5 minus, in parentheses, 3 minus 2x equals 3 times x plus 1 minus 5. Okay, first thing we're going to do is to simplify both sides. Here we have to distribute a minus 1 through the parentheses. Minus 5 to minus 1 times 3 is minus 3. Minus 1 times minus 2x is plus 2x equals 3 to be distributed through the parentheses. 3x plus 3 minus 5. Now let's combine the constant terms on the left here. We have 5 minus 3, 2 plus 2x equals 3x plus 3 minus 5. That's going to be minus 2. And now we'd like to get x alone on one side of the equation. So we can decide to bring the variable x to this side and the constants to the other, or the other way around. It doesn't matter. Let's say we subtract 2x from both sides of the equation. We get that 2 is equal to, here the 2x's cancel, 3x minus 2x is x minus 2. And here, adding 2 to both sides of the equation, we have x equals 4 as our answer. And this is easy enough to check in the original problem. 5 minus, in parentheses, 3 minus 2 times x, 2 times 4, should be equal to 3 times 4 plus 1 minus 5. Okay, let's see what we have. 5 minus 3 minus 8. It's not 3 minus 2, 1 times 4. Order of operations, the multiplication comes before the subtraction. Okay, 5 minus, now 3 minus 8, that's minus 5. 5 minus a minus 5 is 5 plus 5, or 10. And on this side, we have 3 times 5 minus 5. 15 minus 5, also 10, so it checks out. In example number 2, we have the following inequality. We want to solve for x. 7 minus 4 times x minus 2, in parentheses, is less than or equal to 23. All right. We don't make this 3 times x minus 2 because of order of operations. The multiplication of the 4 through the x minus 2 here has to come before the subtraction. So we have 7. In fact, you can distribute, instead of just 4, minus 4. You have minus 4 times x is minus 4x. Minus 4 times minus 2 is plus 8, less than or equal to 23. Minus 4x plus 15 is less than or equal to 23. Adding the 7 and the 8. And now subtracting 15 from both sides of the inequality. Minus 4x less than or equal to plus 8. Now, when we're working with an inequality, when it comes to addition or subtraction, there's no problem. We can add the same quantity to both sides of the inequality or subtract the same quantity from both sides of the inequality, and we keep the same direction. When it comes to multiplication or division, if you're multiplying or dividing by a positive number, you keep the same direction. But if you're multiplying or dividing by a negative number, then you reverse the direction of the inequality. And what we have to do in order to solve for x here is to divide by minus 4. So we would like to divide both sides by minus 4, but the direction less than or equal has to be reversed since we're dividing by a negative, and we turn it into greater than or equal. Now here, the minus 4's cancel, giving us x greater than or equal to minus 2. In problem 3, we have an equation involving fractions. 6x minus 5 over 6 minus 2x minus 3 over 4 equals 2/3. Now, the way to handle an equation involving fractions is to multiply both sides of the equation by a number so that sufficiently large so that all of the denominators will cancel out. We will clear fractions. And the number that we use is the LCD of the denominators here, the smallest number that has 3, 4, and 6 as factors, and it turns out to be 12. That's fairly easy to work out here. We have rules for finding the LCD. We factor each denominator completely. Constants we take down to their prime factors, and we take each factor the greatest number of times it appears in any one denominator. Okay, in this case, it's sort of obvious what the LCD is. We now multiply both sides of the equation by 12. This will clear all fractions, and then we'll have just a regular equation without fractions, which we already know how to handle. So let us distribute the 12 here through. Okay, multiply this by 12, take away this times 12. Okay, 12 times 6x minus 5 over 6 minus now 12 times 2x minus 3 over 4 equals 12 times 2/3. Okay, here 6 goes into 12 twice. You can think of this as 12 over 1 if that helps you. Okay, so how many 6's in 12 is dividing numerator and denominator by 6. 6 divided by 6 is 1. 12 divided by 6 gives us 2. So we wind up with 2 times 6x minus 5 here. Take away. Dividing numerator and denominator by 4, we get minus 3 times 2x minus 3, parentheses. And finally, 3 goes into 12 4 times. 2 times 4 gives us 8. Now, here we have to distribute the 2 through the parentheses. 12x minus 10. Okay, and here distribute the minus 3 through the parentheses. So minus 3 times 2x is minus 6x. Minus 3 times minus 3 is plus 9 equals 8. Now, combining like terms, 12x minus 6x gives us 6x. Minus 10 plus 9, that's minus 1, equals 8. Adding 1 to both sides, we get 6x equals 9. Dividing both sides by 6, x equals 9/6, and we can reduce to lowest terms. We can divide numerator and denominator by 3. 9 divided by 3 is 3. 6 divided by 3 is 2, for a final answer of 3/2. So x is equal to 3/2, and this can be checked also in the original equation. When you substitute in 3/2, okay, times the 6 gives us 18/2. 9 minus 5, 4/6. Okay, when you substitute in here the 3/2, you get 3 minus 3 is 0. So here you have 4/6 should be equal to 2/3, and of course 4/6 is equal to 2/3. In problem number 4, we have the following equation: 3x times x minus 4 equals 2x times x minus 2 minus, in parentheses, 12 plus x. Okay, we distribute 3x through the parentheses, giving us 3x squared minus 12x equals, distribute the 2x through the parentheses, 2x squared minus 4x, and finally minus 1 to be distributed through the parentheses, minus 12 minus x. Now let's combine like terms. On the left side, we're already simplified. On the right side, we have 2x squared minus 4x minus x is minus 5x minus 12. Since it's going to be a quadratic equation, let's put it into standard form. That is, everything on one side equal to 0. Okay, so we can subtract 2x squared from both sides of the equation. In an effort to bring it over here, we can add 5x. Let's see what we have so far. X squared minus 7x equals minus 12. And then finally, to add 12 to both sides of the equation. X squared minus 7x plus 12 equals 0. Now we have a trinomial. We'll try to see if we can factor it write it as a product of two binomials. To do that, we need two numbers which multiply to plus 12 and add to minus 7. And they, of course, are minus 3 and minus 4. And we would check this by FOIL, x squared minus 4x minus 3x minus 7x plus 12. So this gives rise to x minus 3 equals 0 and x minus 4 equals 0, x equals 3, x equals 4 as two solutions. Okay, I just want to mention that when I started this problem, I really didn't know what was going to happen. For example, it could have been that I had a 3x squared here, but also a 3x squared here, and the x squareds could have canceled out, and I could have had a first-degree equation. If that were the case, then of course I would have wanted to get x alone on one side of the equation, everything else on the other. But since it's reduced to a quadratic equation, I'm trying to put it into standard form, and I'm trying to solve it by factoring. By the way, the two solutions here, of course, can be checked. Let's try to do that. We have x equals 3 and x equals 4. The original equation, of course, is 3x times x minus 4 equals 2x times x minus 2 minus, in parentheses, 12 plus x. So when we substitute in x equals 3, we get 3 times 3 times 3 minus 4 should be equal to 2 times 3 times 3 minus 2 minus 12 plus 3. This is 9 times minus 1 should be equal to 6 times 1 minus 15. And of course, we have minus 9 equals 6 minus 15 minus 9, and it checks out. Now let's try x equals 4. We'll get 3 times 4 times 4 minus 4 should be equal to 2 times 4 times 4 minus 2 minus, in parentheses, 12 plus 4. Now, on the left side here, we have 12 times 0, which, of course, is going to be 0. And on the right side, we have 2 times 4, that's 8, times 2 minus 12 and 4, 16. And that's 16 minus 16, which also equals 0, so it does check out. In problem 5, we want to solve and also sketch the solution set on the number line. And we have the following inequality. We do not jump in and make 9 minus 4, 5. We realize that order of operations tells us this multiplication comes first. So we have 9. Now distribute the minus 4 through the parentheses. Minus 4x plus 8 less than or equal to minus 3. That gives us, combining the constant terms, minus 4x plus 17 less than or equal to minus 3. Now subtracting 17 from both parts of the inequality, minus 4x is less than or equal to minus 20. And finally, we would like to divide both sides by minus 4 in order to get x alone. But to do that, we're dividing by a negative, and of course we reverse the direction of the inequality, and we get, for a final answer, x greater than or equal to plus 5. And this would be indicated on the number line as follows. If here is 0, 1, 2, 3, 4, 5. We want all those values greater than or equal, 5 and greater than or equal to 5. We can indicate that by a filled-in circle on the 5 and then moving off to the right. If it was x greater than 5, strictly greater than 5, we would use an open circle like that to indicate greater than 5, but it does not include the 5. Filled in means 5 is included in everything greater than 5. Okay, in problem number 6, we have the following equation involving fractions. We have x over 3 minus x plus 2 over 2 equals x minus 8. And once again, to handle this, we'll simply multiply both sides of the equation by the LCD, which happens to be 6. Okay, multiply both sides of the equation by 6 in order to clear fractions. So we'll have 6 times x over 3 minus 6 times x plus 2 over 2 equals 6 times x minus 8. Okay, 3 goes into 6 twice, leaving us with 2x, minus 2 goes into 6 3 times, leaving us with 3 times x plus 2 equals 6 times x minus 8. Now, using the distributive law, we have 2x here. Now, minus 3 to be distributed through the parentheses, giving us minus 3x minus 6 equals, and here distributing 6 through the parentheses, 6x minus 48. Well, 2x minus 3x, that gives us minus 1x minus 6 equals 6x minus 48. Okay, it's a first-degree equation. We're going to try to get x alone on one side and constant on the other side. We can subtract 6x from both sides of the equation. Minus 7x minus 6 equals minus 48. And then, let me just write that up over here again. Minus 7x minus 6 equals minus 48. Then we can add 6 to both sides of the equation, giving us minus 7x equals minus 42. And finally, to get x alone, we divide both sides by minus 7, giving us x equals plus 6. And we can check in the equation x over 3 minus x plus 2 over 2 equals x minus 8. Letting x equal 6. 6 over 3 minus 6 plus 2 over 2 should be equal to 6 minus 8. And we get here 6 over 3, that's 2, minus 8 over 2, that's 4, should be equal to minus 2. And of course, minus 2 equals minus 2. It checks out. Okay. In the last of our equations, we have 5 over 2x plus 4 minus 4 over x plus 2 equals 3/2. Since it's a fractional equation, we would want to find the LCD. We factor each denominator completely. This is really 2 times x plus 2. Okay, then it becomes apparent that the LCD is simply 2 times x plus 2. Each of these denominators is a factor of this denominator, and multiplying both sides by this will clear fractions. Okay, you could have used, say, 2x plus 4 times x plus 2 times 2. The product of the denominators, obviously each denominator would go into that, but that would make the problem more complicated. We look for the smallest quantity so that each of these denominators is a factor. So that's why it's helpful to factor here to see what it's really composed of. Now we'll multiply each part here by both sides of the equation by 2 times x plus 2. So we'll have 2 times x plus 2 times 5 over 2x plus 4, which is 2 times x plus 2, minus 2 times x plus 2 times 4 over x plus 2 equals 2 times x plus 2 times 3/2. Okay, remember, this can always be thought of as over 1, so we're really multiplying fractions all the way across. Here, the 2 times x plus 2 cancels, and leaves us with just 5. Here we have minus. Here the x plus 2 cancels, leaving us with 2 times 4, or 5 minus 8 equals, here the 2's cancel, leaving us with 3 times x plus 2. So we have 5 minus 8, or minus 3, equals 3x plus 6. 3x plus 3 times 2. Just don't write 3x plus 2 and get careless. And trying to get x alone, well, it's there, so let's take 6 away from both sides. And then we'll have minus 9 equals 3x. Divide both sides by 3, giving us that. Here we have x equals minus 3. And let's check our answer. Okay. It was 5 over 2x plus 4 minus 4 over x plus 2 equals 3 halves. And we're checking x equals minus 3. So 5 over 2 times minus 3 plus 4 minus 4 over minus 3 plus 2 should be equal to 3 halves. We have here 5 over, now, minus 6 plus 4 is minus 2. Minus, now, 4 over minus 3 plus 2 is minus 1. Should be equal to 3 halves. Minus 5 halves plus 4 should be equal to 3 halves. And if you realize that 4 is really 8 halves, in order to add the fractions, we think it's 4 over 1. We build a fraction equivalent to it with the denominator 2. We see that it does work out. 3 halves equals 3 halves. And it checks out. Okay, in our next example, 8, we would like to solve for x the following equation. 2x squared minus 4x plus 2 equals x squared plus x plus 7. Okay, we'd like to get it. Well, it's we have a second degree term here. We see when we subtract x squared from both sides, it will not drop out, so therefore it's going to be a quadratic equation, and we'd like to get everything on one side equal to 0. So we can subtract x squared from both sides, subtract x from both sides, and subtract 7 from both sides. This, of course, will give us just 0 on the right, and on the left we'll have x squared minus 5x minus 5 equals 0. All right, now we could try to solve this by factoring, in which case we'd need two numbers which multiply to minus 5 and add to minus 5, and you're not going to find two integers which do that. So rather than going to completing the square, let's go right to the quadratic formula. We try to match this to ax squared plus bx plus c equals 0. And if we can do that, then of course the solutions will be given by x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, we see that a is equal to 1, b is equal to minus 5, and c is equal to minus 5. X equals minus b, minus or minus 5, plus or minus the square root of b squared minus 5 squared minus 4 times a, which is 1, times c, which is minus 5, over 2a, that is 2 times 1. So let's see what we have here. Minus or minus 5, that's plus 5, plus or minus the square root of. Here we have minus 5 squared, that's 25, minus 4 times minus 5, that's plus 20, over 2. Let me just write that. We have x equals 5 plus or minus the square root of 25 plus 20 over 2. So that gives us 5 plus or minus the square root of 45 over 2. And if we would like to put this in simplest radical form, we could write 45 as 9 times 5. So this is the square root of 9 times the square root of 5. So we get x equals 5 plus or minus the square root of 9, that's 3, the square root of 5 over 2. So x equals 5 plus 3, the square root of 5, and x equals 5 over 2, and x equals 5 minus 3, the square root of 5 over 2. We get 2 solutions. Okay, in problem number 9, we have the following. Solve for x and y. And we have a system of 2 equations and 2 unknowns. 4x minus 3y equals 14. 3x minus 5y equals 5. All right, and to solve this by elimination, we would like to multiply the top equation by something and the bottom equation by something so that when we add, either the x's or the y's will drop out. So if we say want to eliminate the x's, we can multiply the top equation by 3 and the bottom equation by minus 4. This will give us, for the top equation, 12x minus 9y equals 3 times 14, or 42. And the bottom equation becomes minus 4 times 3x. It's minus 12x. Minus 4 times minus 5y is plus 20y equals minus 20. Adding now, we see that the x's will drop out. 20y and minus 9y gives us 11y equals 42 minus 20, which is 22. Dividing both sides by 11, y equals 2. Now, substitute into any of the equations. We can pick the first one, 4x minus 3y equals 14. Let y equal 2 here. 4x minus 3 times 2 equals 14. 4x minus 6 equals 14, adding 6 to both sides. 4x equals 20. We get x equals 5. So our answer is x equals 5, y equals 2. We should then check them in the equations. Okay, assuming we haven't done anything wrong. Of course, it'll work in the first, because that's what we use to find x. 4 times 5, 20, minus 3 times 2, 20, minus 6 equals 14. That checks out. 3 times 5, 15, minus 5 times 2, minus 10. 15 minus 10 equals 5, and that checks out. In our next example, 10, we want to sketch the graph of the following equation. And label the intercepts. And the equation is 2x minus 7y equals 14. Of course, it's the equation of a straight line. X and y both appear to the first power here. And we say if x equals 0, we can find the y-intercept. We set x equal to 0, we get 2 times 0 minus 7 times y equals 14. Two times 0 minus 7 times y equals 14. It's 0, so it's minus 7y equals 14. Y equals minus 2. That would be the y-intercept will be minus 2. And setting y equal to 0, in the original equation, we get 2x minus 7 times 0 equals 14. 2x equals 14. X equals 7. 7 is the x-intercept. That is, it crosses the line crosses the y-axis at -2. And the x-axis at 7. Goes through the point, therefore, 7, 0, and 0 minus 2. And it looks something like that. So we set x equal to 0 to get the y-intercept, and y equal to 0 to get the x-intercept, and then we draw the straight line. Okay? All right, in problem 11, we have the following. Find the area of the following figure, which is a square triangle combination. Okay, what we have is this. We have a square here. And a triangle there. This is a right angle. This is a right angle. This is a right angle. Let's say the length of this side is 5, and the side of the square is 13. And we want to find the area of that figure. The first thing to do, of course, would be to put in the other side of the square, so we see that we have this right triangle square combination, and if it's a square, these are, of course, going to be right angles. All right. Now, to square all four sides of the same length, so this is 13, 13, and what's most important, this is 13. Okay, the area is going to be the area of the square, the area of the square plus the area of the triangle. Now, the area of the square is going to be the length of a side squared, that is 13 squared, s squared for the area of a square. The area of a triangle will be 1/2 base times height. Now, let's call the base here b. The height we know is 5. 1/2 base times height. So we know the height is 5. The question is, what is the base? And that's what we have to find. This is b. Okay, but b is a leg of a right triangle, and we know the other leg, and we know the hypotenuse, so we can make use of the Pythagorean Theorem, which says that 5 squared here plus b squared is going to be equal to 13 squared. The square of the hypotenuse is equal to the sum of the squares of the other two legs. That is 25 plus b squared equals 169. b squared is 169 minus 25, or 144. b is plus or minus 12, but of course only 12 makes sense if it's the length of the side here. So we now know that b is equal to 12. So it'll be the area of the square, which is s squared, or 13 squared, plus the area of the triangle 1/2 base times height, 1/2 12 times 5. And that gives us 169 for 13 squared. 2 goes into 12 6 times. 6 times 5 is 30. 169 plus 30 for a total of 199 square units for the area of this figure. 199 square units. In problem 12, we want to find the area of the shaded portion of the circle with center O. And here we have the circle. Here is the center O. And we're given the following. We want to find the area of the shaded portion of the circle. Okay. The area of the shaded portion of the circle. They also told that this is a right angle and the length of the radius here. Length here is 6. Make sure you can see this here. 6 represents the length there. The area of the shaded region. Okay, it's the area of the circle. Take away the area of the triangle. That'll leave us with the shaded region. The area of the entire circle, take away the area of the triangle, which is not shaded in. Now, the area of a circle, of course, is pi r squared, and we're shown here that a radius of the circle is 6, so it's pi r squared, or pi times 6 squared, minus the area of the triangle. Now, it's a right triangle, and if this is a radius of the circle, so is this, and all radii of the circle are equal, so this is also 6. And in a right triangle, instead of 1/2 base times height, you can use 1/2 the product of the legs, because either leg could be thought of as the base and the other one as the height. So we get 1/2 base times height, 1/2 6 times 6, giving us 6 squared, 36 pi, minus, now 2 goes into 6 3 times, so minus 18. 36 pi minus 18 square units. In problem 13, we want to find the perimeter of the following figure. And arc CD in the figure is a semicircle. And we have this. Here we have C, here is D, E, there's A and B. These are right angles. CD is a semicircle. We are told that AB has length 20, AE has length 10, and DE has length 12. And we want the perimeter, that is the distance around the entire figure. Okay. CD is the diameter of a circle. This is a semicircle. Since 20 measures the distance from here to here, if from E to D is 12, it stands to reason that from C to D is 8. 12 plus 8, 20 must match this, which is 20. Therefore, since this is the diameter, the radius of the circle is 4. Now, the circumference of a circle is 2 pi r. So the circumference of this, if it had been an entire circle, would be 2 pi times 4, or 8 pi. But because it's only a semicircle, the distance from here to here is only going to be half of the distance around the entire circle, or only 4 pi. Now, furthermore, if AE is 10, then BC is also going to be 10. And we get for the perimeter, let's start at A and work around this way, 20 A to B plus 10 plus 4 pi plus 12 plus 10. 20 plus 10 plus 4 pi plus 12 plus 10. It's giving us a total of 30, 40, 52 plus 4 pi units. That is not 56 pi. If it was 52 pi plus 4 pi, that would be 56 pi. This is 52 separate plus 4 times pi, pi being a number a little over 3. In problem number 14, we have the following. A, E, B, C, and D. This is 30 degrees angle E. This angle in here is 50 degrees. And CD has length 4. BD has length 6. BE has length 9. And we're given that AE is parallel to CD. Find, first we want to find angle C, and then in part B we want to find the length of AE. All right, we start as follows. We have here vertical angles, CBD and EBA, and they're going to be equal, so then I know that this angle is also 50 degrees. Its vertical angles are equal. We have a triangle here, and the sum of the angles in a triangle is 180 degrees. So since we have 30 and 50, that's 80. This must be 100 degrees, angle A. So that it's 100 plus 50 plus 30, 180 degrees. Now we're looking for angle C, but we know that CD is parallel to AE. Think of these as parallel lines, and AC is a transversal which cuts them. The alternate interior angles are equal. We have a situation like this. These angles are equal. So this is 100 degrees. Angle C is also 100 degrees. And that answers the first part. Angle C, 100 degrees. Now, since this is 100 degrees, this is 50 degrees, this must be 30 degrees since the angles have to add up to 180 degrees. Furthermore, what this tells us is that these two triangles are similar. Triangle ABE is similar to triangle BCD because we have 3 angles in one equal to 3 angles in the other. Now we want to find the length of AE. AE. Here it is. Okay, we know that corresponding sides of similar triangles are in proportion, so we can set up a proportion which we can find the length of AE. We'll do it like this. We'll say the length of AE over the length of BE is to the length of CD over the length of BD. Now look how I work this out. These triangles are similar. AE is opposite the 50-degree angle, and BE is opposite the 100-degree angle. So if this is opposite 50 and this is opposite 100, then in the other triangle I want to do the same thing. Opposite 50 I have CD, and opposite 100, I have BD. So that the proportion matches. Check it with the, just don't go by what looks right, work with the angles. If it's opposite 50 in this, it's got to be opposite 50 in that. Okay, let's call the length of AE X. So we have X is to the length of BE, which is 9, as the length of CD, which is 4, is to the length of BD, which is 6. And we can multiply both sides of this equation by 9 to give us that X equals 4 times 9. Here the 9's cancel. 4 times 9 over 6. 36 over 6, or X equals 6. So the length of AE is 6. And we get 6s to 9 is 4s to 6. They both reduce to 2/3. Okay. In the following, we have this. A farmer has a fenced-in yard in the shape of a right triangle. The legs of the triangle are 9 feet and 12 feet. If the farmer wants to take down the whole fence and use all of it to enclose a square yard, what will be the area of the new square yard? He has a fenced-in yard in the shape of a right triangle. And the legs of the right triangle are 9 feet and 12 feet. The legs, not the hypotenuse. He's going to take down the whole fence and use all of it to enclose a square yard. And he wants to know the area of the new square yard. Okay, first we're going to find the hypotenuse of the triangle here. The perimeter, the amount of fencing that he has is, of course, 9 plus 12 plus x. That'll be the total amount of fencing that he has. Okay, and then we'll use that to form a square. So to begin with, we have that 9 squared plus 12 squared is equal to x squared, the Pythagorean Theorem. And that's 81 plus 144 equals x squared, or x squared equals 225. And that's a perfect square, and we get that x equals 15. Not minus 15, since it's the length of the hypotenuse here. X equals 15. Therefore, the total amount of fencing that he has, these are all measured, of course, in feet, would be 9 plus 12 plus 15 feet. Well, the total is 27 plus 9, 36 feet. Now, he's going to use that to form a square. Let's say the length of side of the square is s. So the perimeter of the square is 4s. And 4s has to come from this 36 he's going to use the entire 36 feet to fence in the square. So from this, we get that S equals 9 feet. Okay, now you always should answer what the question asks. It says, what will be the area of the new square yard? Not just the length of the side. The area is, of course, S squared. The area will be 9 feet squared, or 81 square feet. That will be the area of the new square yard. Okay, now that's going to bring us to the end of this tape. You now have a review for your final exam. We didn't have time to get to word problems other than just this one, so it would be a good idea to also go over the videotapes in which we have the word problems.